This is Dr. Satish, Assistant Professor at British Applied College. I welcome you all to this video lecture. This is for ENG110, Computer Aided Design in Engineering. This is a Level 3 unit for Pearson Subsidiary Diploma in Engineering. In this video, I will teach about the remaining part of the assembly. In my last video, I showed you how to model the parts, the 5 components of flange coupling. Now in this video, let me explain how to assemble them together in FreeCAD. So to do the assembly, there are a number of workbenches like assembly 2 plus, A2 plus, assembly 2, 3, 4. Okay, but if you have work experience using SolidWorks, then A2 plus may be the best one to use in FreeCAD. So again, this is an external workbench. This is an default workbench. You have to download and install from Tools Add-on Manager. So here is my FreeCAD. I will go to Tools, Add-on Manager. I will search for A2 plus, and I will install it. Okay. So once I install, I have to restart the FreeCAD. So the FreeCAD will be restarted, and meanwhile you can see the assembly file here. Okay. So in the assembly file, I can see the flange and a shaft. Okay. There are 2 flanges and 2 shafts on either ends, and there is a taper key, 2 taper keys on either ends, and 4 bolts and 4 nuts. Okay, as given in the bill of materials here. Okay, so 2 flange, 2 shafts, 2 taper keys, 4 bolts and 4 nuts. Now I will create a sub assembly. Okay, I will not import 2 flanges and made it to I will assemble it together, then again 2 shafts, 2 taper keys. Instead of that, I will make one sub assembly. I will make one pair, okay, of flange, shaft and taper. Then later I will import another pair, and I will bring I will assemble it together. Okay. Now let me go to FreeCAD. So let me choose A2 plus. I will create a new file. So once I create A2 plus, you can see these 2 toolbars appearing here. In these 2 toolbars, the bottom one I can use it to import, and the top one is for giving constraints and checking my degrees of freedom and everything. So I will just import a part. So yes, before inserting I have to save the assembly. I will save it. I will go to documents, recordings, assembly. Okay, so I will create this as a sub assembly. I will just give a name sub assembly, and I will try to import my flange. So the first component, like SolidWorks, the first component you import, it will be fixed. Okay, when you import other components, when you are going to import the other components like shaft, okay, we have to give mating conditions. So if you properly understand assembly, how to do assembly in CAD softwares, you have to give at least 3 mating conditions to properly fix 2 different parts. The first part which you introduce will be always fixed. For example, the flange here, it is always fixed. When you try to move it, see, this is called as move the selected part under constraints. When you click it, when you try to move it, you cannot move because it's fixed. Okay, but if I import a shaft, okay, so this is my second component. Whenever I introduce a second component, this can be easily moved. See, here I give the same, move the selected part under constraints. If I try to move the shaft, you can easily move it. Okay, so the first component will be always fixed. The second component, we have to create the mating conditions such that they can be assembled into together. Okay, so the mating conditions, I say 3 mating conditions should be provided. Only if you give 3 mating conditions, it will be properly fixed. Okay, it will be properly assembled to the new part will be properly assembled to the fixed part. Now so if I click the edges, okay, the first thing is I have to make sure this goes inside this. Okay, so if I go into the assembly file, I can see this outer part is on the other side. Okay, so see, this should come over this side, Okay, so what I will do is, first I will select these two. Okay, I will select the inner part. I will select the inner part of the flange and the outer part of the shaft. Okay, so once you select, can you see the constraints? Okay, the constraints which are possible alone will be appearing. The other constraints will be grayed out. Okay, so here I have two constraints: axis coincident constraint and axis parallel constraint. So I want these two axes to be coincident. Okay, only then I can insert the shaft into the flange. So I will click this. So once I click this, you can see it has properly done. Okay, but I want this side to appear on the other part. Okay, so what I will give is, I will give flip direction. So once I give flip direction, you can see it has flipped its direction. Now I will just give slow solve and accept. Okay, so if you check, this is my, to check the degree of freedom, this is my icon. Okay, if you click the degree of freedom, it will show you the shaft has 2 degrees of freedom. Okay, and the flange which I introduced, which I imported it first. Okay, it is fixed. Now I have to by giving if you click here, you can see I have given one mating condition between flange and shaft. I have to give 2 more to properly assemble it to the flange. Okay, now now what I will do is I will click, see, I can move the shaft. Okay, if I click this, move the selected part on the constraints, see, I can move the shaft. Okay, I cannot move it in other directions because the reason is we have made the axis to be coincident. So I cannot move it on any other plane. Okay, I can just move it along the axis. That is the only part possible. Now what I will do is, I will try to give this, and okay, so let me look into this. I am trying to give these 2 parts. Okay, on I am selecting both the right sides. Okay, once I select both the right sides, what I get here is, you can see now there are other sets of constraints appearing, but not the former ones. So and the former ones are grayed out. Okay, you can see that here. Now I can have planes parallel constraint and planes coincident constraint. Okay, so what I will give is, I will give planes coincident constraint here. I will solve it, and I can see, can you see, the shaft has turned actually. Okay, the shaft was in the other in a different rotation. Now it has turned such that both are both the things are now in constraint. Okay, so if I solve it, if I accept it, now things are fine. Okay, so now I have constrained 2 things. If I check degrees of freedom now, see, still only 1 degree of freedom left. That we will do it now. So I will go for here. I know these 2 axes. Okay, these 2 has to be in line. Okay, because if you see the assembly drawing, they have to be in line. Okay, so once you select these 2, you can see this. Okay, axis coincident, which already we gave. Okay, and this is circular edge constraint, and this is axis parallel. Okay, so what I will give is, I have to give point on line constraint and point identity constraint, and here this is peer identity constraint. I think I should give circular edge. Okay, let me try. Yes, so once you give circular edge, this is properly fitted. Okay, so if you accept, and if you give the degree of freedom now, see, both the degree of freedom, one is fixed, the other one is 0. Okay, so if you try to move now, okay, you cannot move it because it's properly assembled. The shaft is properly assembled to the flange. See, if I click this and if I try to move it, no, I cannot move. Okay, so this is how it works. Now let me try to insert the shaft, taper key. So I will include the taper key here, open. Okay, so in my taper key, as I said, one end is 9 mm, the other end is 0.8 less than 9, which is 8.2 mm. So I'll just measure to make sure which is my 9 mm end. Okay, so this is my 9 mm end, so I'll just delete it, and this 9 mm goes on the right side. Okay, like here, this part, this part is where 9 mm goes. So what I will do is first I will select the 9 mm edge. Okay, so I will select this edge and I will select this edge. Okay, this both I will give axis parallel, solve, accept. Okay, now I will sorry, I think there's a mistake. 1 minute. I'll just, no, it's fine. Okay, so I will select the bottom of this and I will select the bottom of this. Okay, so I will give this as okay, I will make sure these are constraint. Okay, plane constraint, so I will give yes. Now I will select this part and this part. Okay, so this is my third mating condition. So if I give plane constraint, it will fit like this. Okay, it's fine. Okay, but still if I check the degrees of freedom, still I have 1 degree of freedom left. So what I will do is I will delete this axis constraint. Okay, I think this is creating an issue. Let me check. Yes, okay, so I will delete this axis parallel between these two. I will delete it, and what I will do is better I will click the top and this top. Okay, so I will make sure this is axis parallel, axis coincident, no constraint mismatch, so I should not do this. Yes, okay, so axis constraint, yes, I will just delete it. And now better I will select this face and this face. Okay, so if I make it constraint, now it solves. Fine, perfect. So this is how I solve it. Okay, now if I go here, see, I have completed this sub-assembly. This is what I wanted to tell. Now I have two ways now. See, now I have this sub-assembly. I will create another assembly file and I will import two of these sub-assemblies and I can bring it together. This is one way. The other way is, again I will import a flange, a shaft and a taper key, and I will attach this to this one fixed see, to this fixed flange. I can do both ways, but the smart way is the first one. Okay, so I will save this. Okay, then I will open a new one. This I will save as a final assembly. Okay, I will save as a final assembly. I will import the sub-assembly here. Okay, so this is my first sub-assembly. So once you import the first sub-assembly, this will be fixed. Okay, as I say always, the first part will be fixed. Now if I import the second sub-assembly, okay, the second copy of it, this will be moved. Okay, if I try to move this, see, I can move this everywhere, anywhere, but you cannot move this one. Okay, because this is the first one I imported, so it will be fixed. Okay, now let me create the mating conditions for this. So it's easy for me. I will click this and I will click this. Okay, I will give plane constraint. Okay, this is the plane constraint one. If I give plane constraint, it will be done, but I have to flip the direction. Okay, see, I have flipped the direction and I give accept. It is fine. Okay, it's done. Now if you see, if I try to move it, you can understand. See, I can move it along this plane. Okay, fine. Now what I will do is, my easiest part here is, I will select sorry, I will select this axis and this, any one. Okay, anyone from either of the flanges. Then I will give axis coincident. Okay, once I give axis coincident and this accepts. Okay, So if I check the degrees of freedom, one is fixed, still 1 degree of freedom is left. Okay, so if I give another mating condition, if you check 2 mating conditions are there, so if I give another mating condition, this degree of freedom will be 0, so it will be properly assembled. Okay, now what I will do is okay, so I'll just delete it now, and I will select this and this, and if I give access coincident, that's it. Okay, if I give solve and accept, it is properly mated. If you check the degrees of freedom now, you can understand the first flange, the first sub assembly is fixed, the second sub assembly is properly assembled, no degrees of freedom. Okay, it cannot move. Now I can insert the bolts and nuts. Okay, so if I can go for the first bolt, I can open it here, I can bring it here. Okay, so again I have to give 3 mating conditions. Okay, so I will select this bottom and this part, I will try to give access coincident. Okay, that is fine. Solve plane constraint. Okay, plane coincident. Now I can select this outer part and this inner part. If I give access, okay, access coincident, it will easily fit in. Okay, so these are the 2 mating conditions that I can provide to a bolt. Okay, but still if you check, there is 1 degree of freedom left. How to solve this is, just now you gave this access coincident, so click the access coincident. Okay, edit it. Here you can see lock rotation false. Okay, if you arrest the lock rotation, if you arrest the rotation, okay, by clicking true here, then it will be properly fixed. Okay, if you see the degree of freedom now the degree of freedom is 0. This is how we do it. Okay, now let me insert the bolt. Let me insert the nut. Okay, so I have my nut here, so I will select this face and this face, the same thing what I gave for bolt. So plane coincident constraint, I give solve accept, and okay, let me select this circle and this, let me select both and let me give access coincident. So the access coincidence is done, and here if I give lock rotation, just let us check again. If I give lock rotation as false, if I give accept, and if you check the degrees of freedom, I'll check the degrees of freedom again. See, still 1 degree of freedom left in the nut. Okay, so again what I will do is, okay, I will go to the nut, I will go to the access coincident, and I will click true. Okay, if I do this and if I give accept, then if you check the degree of freedom, then it's proper. Okay, all the degrees of freedom are properly arrested. So I will go to the isometric view and fit all. Okay, so this is how my flange coupling look like. So you can repeat the bolt and nuts, okay, for the other 3 holes, and you can complete this. Okay, thank you all.